Okay, so for the last video for today, and I'll try to keep this one pretty short, I'm going to just finish question 2 and then maybe look at that next quick example, and then we'll call it a week. But recapping on this one, so again, I found the period to be 2. Because I knew where the amplitude was, if I broke it up into every 0.5 seconds, I knew that it should progress a quarter of the way through the motion. So after 0.8, it was down here. And then at 1.3 seconds, right, at 1.3 seconds, that's when it should be at the negative amplitude of 0.25. So I hope I didn't go through that too quickly, but I do expect us to be pretty comfortable making that graph by plotting the amplitudes and finding those points. This is definitely a tough question. That's why I did want to make time, to set this aside. You guys can imagine if there's a question like this on the quiz or test, it's going to take a little bit. And obviously the best thing you can do is just practice this type of thing a couple times as it goes. So if you ever feel like you need more practice, that's cool. Just let me know and I would be happy to give you some more examples to practice. But anyway, let's finish out part B to this question as well. We really have done the toughest part. Part B just needs to make sure that we clean it up in terms of using some trig to help us figure it out. So they ask us for part B, at what times during the cycle does it pass through 20 centimeters? So the tricky thing about 20 centimeters is not like at one of my amplitudes. So as I go through this, right, man, it would have been nice if they had asked me when is it 25 centimeters, because I already know 25 would be at 0.3 seconds here and then again at 2.3 seconds over there. But obviously that's not the case. That's not what they ask us for. So they ask us 0.2, right? During the first cycle, when does it pass through 0.2 seconds? And if we look on our graph, we can identify those spots fairly quickly. But I don't necessarily want us to have to guess and check, right? So like if I were looking here, hey, there's 0.2 seconds right there. And then on the other side, there's 0.2 seconds right there. But I don't know exactly what time that is by looking at my graph, but it will help me kind of double check my answers to make sure they seem reasonable. But the way we can do this, don't make it worse than it is, we've got our function now, and our function relates position to time. So now that I have my function, and yes, I'm sure some of you are like, why has he not canceled the 2's out? I don't know. You can do that if you like. But as I look at this function, all I have to do then is just plug in 0.2 and then solve again. I just have to be careful, as always, when I'm solving with my cosine, right, that I'm considering the possibilities. So as I set this up, I divide it over. Again, I'm going to go ahead and keep it as a fraction, so 4/5. So if I divide the 0.2 by 0.25, and then cosine of pi t plus 5.36. Okay, so I do this, and then I can cosine inverse both sides, right? When I do that, that cancels that out. So once again, 4/5 is probably not a cosine value that most of us just know offhand. It's not one of our common unit circle values, so you don't just look at that and say, oh yeah, that's pi over 3 or whatever, right? But we can still use our handy-dandy calculator to help us out with this. We just have to consider again, what does that actually mean for us? So if I use my calculator to evaluate this, if I'm in radian modes, and make sure you're in radian modes, this will give me 0.6435 as my value, right? Now again, I have to consider though that is that the actual number that I want, or do I need to think this through some more? So let's go back to our unit circle. The 0.635, I know that is a brilliant unit circle. Let's try one more time there. That's a little bit better. So the 0.6435 would represent the positive angle up here, where cosine is at 4/5, right? But I know that it could also happen then at negative 0.6435 down here as well. Now here's what I have to consider. I have to consider my starting point, my phase constant, right? Where did I start? And then where are those two locations? Because I know that I want to find it the first time through. So 0.6435, I'm not actually going to use that value, but because I started at 5.36, so I started here on my unit circle. So the two values that I'm going to use are actually going to be 2 pi minus 0.6435, which if I calculate that, ends up being 5.64. And 5.64 is good because it's a little bit past the 5.36 that I started at, right? So if I'm starting at 5.36, the first time that I get through this location of 4/5 is going to happen when I'm now at an angle of 5.64, right, measured from the positive x-axis. Definitely take your time on this, pause it, make sure that that makes sense right there. but I'm choosing that relative to my point. Now, if I had chosen to start with negative 0.93, then the first point that I would use would be the negative 0.6435, because that would be, again, the same part of my circle. I'm just finding the angles that are adjacent to those, right? But I'm going to stick with the 5.36 so that it doesn't get too confusing. The next time that I pass through this point would be up here, right? So the first time would be here at 5.64. The next time that I pass through would be up here. If we're trying to find the total angle as we've gone all the way from the start all the way around to that point, right? If we're trying to find that whole angle, don't make it worse than it is. It's simply going to be the 0.6435 plus 2 pi for one full circle. So the other location that I'm going to do is going to be 2 pi plus 0.6435. And that gives me about 6.93. So that tells me then that these are the two locations for which I should be crossing that point. So then if I take this and kind of quickly plug this back in for my value here, so I'm going to do 5.64 first, equal to pi times t plus 5.36, right? This is easy enough for me to solve. Now if I solve this, so if I subtract the 5.36 over and then divide by pi, I get the first time that this happens to be about 0.09 seconds. And that actually makes a lot of sense based on my graph, because my graph said around 0.1, that's where I should be at that. So that actually looks really good, right? And kind of confirms, yeah, that makes sense for me. If I look at my next one, so if I look at the 6.93, then solve this one, same idea, right? Subtract the 5.36 over, divide by pi. I get t equals 0.51 seconds. And again, that actually kind of makes sense. So the second time, but if I look at my graph over here at 0.4, 0.5, again, my graph's not perfect. It's not scaled proportionally there, but 0.5 seems to make a lot of sense for the next time that I might be passing through. The other thing that you could do that's kind of a clever way to notice is, notice that the amplitude happened at 0.3 seconds, and notice that these are actually equal times from 0.3 seconds. This is a change of 0.21. This is another change of 0.21. So it actually is showing us that symmetry that we would expect with a cosine type curve. Okay, so obviously question 1 here is a very tough question, right? I'll make sure we have some time next week to practice these types of questions a little bit more, because they are challenging, right? It's kind of like what we did last year, except we're taking it to that next level, which isn't necessarily a lot of calculus, but it's a lot of trig, and it's definitely needing to make sure we understand the unit circle. Okay, so bit of a doozy. Don't let that intimidate you. Just realize this is something we're going to have to practice. The last example that I want to do then is just this real quick check, and then we'll wrap up here and we'll call it a week. And you guys can use the rest of the hour to work on homework, or maybe just practice a question like that one again. Maybe just run through it again if you feel like that's helpful. But let's look at this quick one. I think this won't be too bad. So this is position graph of a mass on a spring. What can you say about the velocity and the force at the instant it's indicated by the dashed line? So we know that we're starting at the amplitude up here, but they're asking us, at that point, what do we know about it? So what would be true about the velocity and what would be true about the force? So if I look at this, the first thing, let's just identify the velocity. And by all means, feel free to pause and answer this on your own first. But at any amplitude, we know that the object should momentarily have a velocity of 0. So at this point down here, the velocity should be equal to 0. So A and B are out, D is out, E is out, and then we've got options C, F, and G. At the amplitudes, remember, that's actually where the acceleration should be the greatest, right? Because that's where, if it's F equals K times the amplitude, that's where X is the greatest, which is where the force is the greatest, which is where the acceleration is the greatest as well. So we have the highest acceleration. So the acceleration is not 0. The force is not 0. So we can rule out G. So then the question is, our force to the right or to the left? We are assuming here that they are indicating standard directions. So typically left is considered negative and positive is considered to the right. Since we're looking at this point where it's at the negative amplitude, that means the acceleration should be going in the positive direction, right? Because if I've been displaced a negative amount, I'm accelerating the other way, right? I'll use capital A there, but I should be accelerating the other way. So the force should be then to the right. It should be in the positive direction. Like I said, I'll go ahead and stop the videos here. Thank you guys for watching all the videos this week. I know it's not the best way to do this, but I hope that it still has helped us continue to move forward in my absence. But I hope to be back next week, so keep working hard, guys, and I'll see you soon.